Okay, so I'm just going to do a quick demo of the generator tool. So when you start up, it's going to look like this. Enter a password, enter a better password than I just entered. I hit the create button. You probably didn't see it. I did it kind of quick. I hit the create wallet button. It pops up. It refreshes the screen. You've got a wallet here. Now, it's actually the mnemonic that you need to record is um, on this screen. So I'm entering my password again. And this right here, you absolutely have to record this. Um, put it in your Gmail so that the NSA can have it, or however that works, or just put it in a safe place. So you absolutely have to record that. You can't count on Chrome or Firefox to necessarily keep that. It will be in local storage. It's encrypted in local storage, but every once in a while, if you run low on disk space, Firefox or Chrome likes to just randomly nuke your local storage. So that's the first thing, is you save that. Um, then you can go back here, and that's the message about backing up. You go back here. This is kind of an advanced thing. Actually, we don't really have to worry about other wallets in the collection now, because we can have more than 1,000 assets, as many as we want in a collection. So probably don't want to use that. Uh, Type in a collection name, a unit name, which is going to be 4 characters, and then the actual numbering is going to come after that, like fuzz001. Supply is probably going to be 1 for unique. External URL is like https yourwebsite.com. The description, this will show up on NFT Explorer. So this is an ARC69 system. So the metadata is gonna be ARC69 when you mint. So then you can go to images code, and um, I think I already actually, this is going to start off blank, but you go and add trait, and then you can go in here, and I've already put some information in here, so I'll delete it. So it's going to start off kind of blank, and you can hit this. You can type a name for the trait, um, arm, weapon, I don't know. You can type a name for the trait, and then you can hit this, and you can select your layer, your images for your trait variants. It's going to upload them, and if they're small, it will be just that fast. But if they're larger images, obviously it won't necessarily go as fast. Let me just briefly explain this business. You need to make sure that there's an image here in this column, otherwise things are not going to work. This right now, the occurrence percent, I think it defaults. See, it's defaulting to 10. You probably want to change that to 0. That's not the best default. But if there's 0, then it means it's going to be an equal chance among any of the different images that you give here. So the offsets and the data is used in the procedural code, which is not necessary unless you're a programmer or you have something a little tricky where you want to sort of have conflicting variants or something like that. But you can ignore that. You can also ignore the offsets. The offsets are really if, for example, you have a background image that's say 2,000 pixels, but you decide that your weapons are going to be much smaller, which is not typically the way that you do it, or if you're using something like placeholder markers in your code. But you're typically not going to need to use the offsets because most people export their images as all the same size. You can probably ignore that. The occurrence percent, as I said, it's going to automatically calculate it if you enter a 0, but if you say you want one to be very common, then you put a 50 there. The rest of these, this will be 1, 2, 3. So what's 50% divided by 3? Whatever that is what will be calculated. And the way that this works is it creates a table and it selects a random number between 0 and 100 for each trait. And so, for example, if I selected if my random number was 60, then it would look in this table and would say, okay, well, we went past the first bucket, and now we're in the second row here, and that row has what 15% or 17% or whatever was calculated. 50 divided by 3. That's math. Anyway, so it would pick a staff if we had a randomly selected 60. So the occurrence percent is an approximate number. This stands for occurrence or rarity. It's not going to come out exactly as that. It's not counting them up to make sure that you have exactly 50% or something like that. It's a random chance that's repeated every time you generate the image. But if you generate 1,000 images, 3,000 images, it's probably going to come out around whatever you put in here, probably. So this, I'm just going to delete this trait because there's nothing in here. So I'm just trying to do a really simple example. Background, layers, background. This is not going to make a lot of sense, but okay, so this is going to be, so now we've got our images uploaded and we've got some names for things. By the way, it'll pick up the names from the images automatically. You can go to generate and let's just see if we can generate 3. Now when it starts out, it's not necessarily going to start very quickly because especially if you have larger images, it can take a while to load up the container that it's running the code and the generation code in, and then cache load the images. But if you generate a bunch of these, then the container is already loaded and the image is already cached in memory, and so the generation can be less than a second, even if you have really large images that you're loading into memory. But so these are just a few small images, so there isn't really a big delay. You can see it's generating it less than a second for most of these. So this is the traits that were selected, and they're all going to be unique. Now the thing about the duplicate detection is you can fool it if you try. So if I go in here and I say, the next step is we can mint it, right? So if I go and I mint it, and then I go back and I say I want to generate some more, and let's say that we decide we wanted to change this background image right here of the shield or something, or we wanted to make a minor change to that. If I do that and then go back to generate and generate some more, the way the duplicate detection works is it uses the content hash, which is the IPFS CID, to identify unique images. So if you mint a batch and then modify some trait images without, say, adding another trait or removing a trait, then you can generate images that are duplicates in terms of the traits selected. Now, the images themselves will not be duplicates because you modified whatever the background, the shield image or whatever, but the actual traits selected will be duplicates, and that's not what you want. So if you need to change something, you probably just don't want to be modifying the variant images after you do a mint. You can do mint in multiple batches, but you can't go back and upload different versions of the variant images unless you add something so that you add another trait like a hat or something like that, and then you're guaranteed that actually the metadata that comes out, the set of traits, is going to be unique versus that previous batch because now they have a hat or whatever they have. So that's just a warning about that. So now, when we go to mint things, um, we're going to have to put some money in here um, if we want to mint. So I would like to do that. I'm going to switch to testnet so I can get free money. Um, and let's see if I can go to dispenser Algorand. Okay. And now, oh, motorcycles. Okay. So I'm going to try to get some free testnet algos. Um, and theoretically, if we wait about 5 or 10 seconds, this will show up. I'm hitting the refresh. Here we go. Okay, so now we've got 10 testnet algos, and we generated 3. So we can now um, mint. I'm going to expand this little status area. Mint. Okay, so it's pinning to Pinata Cloud, however you say that. Um, and it went ahead and minted on testnet. Um, so these are the ones. What it's doing with this already minted section is it's doing asset config transaction queries. So if we go to Algo Explorer and find testnet and look for that asset, there's our test, and it was minted with the IPFS URL, and we should be able to see, here's our ARC69 information. These are the traits. So for testnet, it's not going to show up on NFT Explorer, and that would probably be good if that was on NFT, if I demonstrated that, but maybe you can take my word for it for this video. These are all going to show up on NFT Explorer. So one other thing about this, um, so if we go back here, um, there is a help section here that explains a little bit of this, which I think people just don't see. But if you're interested in using the procedural code generation, probably you should just ask me. But um, also, I do have some explanation here. So um, the backend is using something called P5JS, and it's the live script programming language, which is sort of a functional programming language that lets you use concise code. Obviously, again, this is not necessary for most projects, and if you have something like you just want to avoid glasses and laser eyes, you can always just ask me, and I can give you one or two lines of code that will take care of that. Um, so where does so this gives some examples of how to use the code. So the code would go in here. So you click on this icon, and the nice thing about this is that we've got, all the code is sort of factored out. So if you're trying to modify the trait definition programmatically, it would go in this tab. If you want to generate something like, just random generative art, it would go in the draw section. And I do have just a little bit of examples. Here's how to do some text. Here's how to do, this one creates something like a magenta flower. Um, and, the easiest thing is just to ask me in Discord what you're trying to do. But this is definitely something that we used for the Matthias Trinley project. And, we reduced the code quite a lot on that. And there's just, a few of these traits where, for example, we want the horns to be the same. So what the trait def says is if the previous horn, if the left horn definition, if the right horn definition is not the same as the left horn definition, then retry. And it's like a one line of code. So there's all sorts of things you can do with this, and the easiest thing is just to ask me if you have an idea or need to prevent laser eyes or something like that. So I think that explains most things um, about the generation. And I do have some other tools. I have the drop manager, the swap creator, and the Mint on demand stuff is going to build off of this. And so I think that stuff is going to go into a separate video, a little bit of explanation of that, how that stuff works. And if you have a question, go to the Discord, click on this Discord thing, and I'm run VNC in there, run VNC, and just ask me, even if it's something basic. Thanks very much.